In this video, I'll be describing the connection between the brain and dance. The dance I'm performing is guided by my partner, who teaches participants with Parkinson's disease. When we dance, we engage multiple regions of the brain in a complex interplay. To begin with, I receive the visual cues for the dance through the retina, and the information travels through the optic nerve and the optic chiasm, becoming optic tracts, which terminate in the lateral geniculate nuclei of the thalamus. Next is the primary visual cortex, which contains retinotopic maps for features such as colour, form, location, and motion. The posterior parietal cortex is most relevant for dance as it's involved in the perception of motion. Additionally, the music is received by the cochlea, and these auditory signals travel down the auditory nerve to the medulla. The signal travels through the lateral lemnisci to the inferior colliculi of the tectum and arrive at the primary auditory cortex, located in Heschel's gyrus in the temporal lobes. Output is routed then to the secondary auditory cortex, where the posterior parietal cortex significantly contributes to the perception of spatial location. Additionally, the proprioceptive system of the somatosensory system uses sensory nerves, dorsal roots, and dorsal columns to carry information to the ventral posterior nucleus in the thalamus and, in turn, the primary somatosensory cortex, where it is interpreted by the somatosensory homunculus and sometimes passed on to the secondary somatosensory cortex. In order to create movement, the posterior parietal cortex communicates what my senses have perceived to the motor areas in the frontal lobe. Most relevant to dance are the supplementary motor area, dominated by somatosensory information, and the premotor cortex, dominated by visual information. Next is the precentral gyrus, where the primary motor cortex contains a somatotopic motor homunculus, which sends messages to the lower levels of the sensory motor system. The descending dorsolateral motor pathways, coordinated and modulated by the basal ganglia, then carry information to the spinal cord, which stimulates movement through the efferent ventral roots.